Greetings everyone, I am Allan Christopher Zeta and I'll be talking about my thesis regarding representations of certain finite-part integrals by integration by parts, which is endorsed by Dr. Eric Galapon. First we talk about divergent integrals. They are different integrals that are non-integrable due to a singular point in the domain of integration. In simpler terms, they blow up. Shown here is an example of a divergent integral with the integral having a singular point at zero, wherein it is unbounded as it approaches that point. To deal with divergent integrals, values are assigned using finite-part integration. Finite-part integration involves expressing the divergent integral in the following manner, where the singular point is temporarily cut out of the domain integration. This expresses the divergent integral as the limit of a convergent integral. The convergent integral is then expressed in the following manner, where the convergent and divergent terms, as epsilon approaches zero, are grouped together. The finite part is then defined to be the limit of all convergent terms as epsilon approaches zero. The convergent and divergent terms are then typically determined by using what is known as the canonical method. However, the canonical method is very laborious, delicate, and will involve intractable expressions. An example is shown in the left, which involves non-trivial limits. As such, alternative methods of calculating the finite parts need to be developed. The method developed in the study involves considering a certain class of finite parts as distributions. Integration by parts is then used to provide new representations for the finite part. Finally, further analysis is done to show that the method holds even if the finite parts is no longer a distribution. Integration by parts allows us to deal with divergent integrals that are intractable with the canonical method. For example, with the new method, we have the following expression that is derived without evaluating non-trivial limits. That's all. Thank you for listening.